do in classification generally? In classification, what you do? You have a large number of data sets. Okay? So when you are doing by a neural network, has to train a neural network. जैसे कि you have a small baby, gradually he or she learns. How he or she learns? By training. Either the training by a teacher. मैं IIT में प्रोफेसर हूँ तो मैं बेटा को ट्यूशन दूंगा, ये दूंगा. Either he learns by teacher, that is supervised learning. और जो झोपड़ी में रहते भी वो भी सीखते हैं. झोपड़ी person is also able to distinguish between a hibiscus and between a rose, although both are red. And my son is also able to distinguish between these two, also that is red. But there is no teacher. That is the learning from the environment, learning from the surrounding. That is unsupervised learning. So for any neural network, there are two types of learning. Either the learning is by a teacher or by some guided principle. बेटा तुम्हारा एरर ये हुआ, इधर मत जाओ, इधर खींच लाओ. So like you are adjusting the error to zero, that is supervised learning, or something you learn by yourself by adjusting it to the nature, that is unsupervised learning. So the neural network classifier is divided into two parts. One is supervised, another is unsupervised. So for this learning process, मैं एक बार लिखा दूंगा बेटे को तो नहीं होगा ना, घोषणा पड़ेगा 10 बार. So अभी ऐसे लिखेगा, फिर बाद में ऐसे लिखेगा. Like you go on learning for a certain number of iterations till the error is zero. So for learning, sufficient information should be given. So these information are nothing but your features. So now what I am doing, I am extracting these features, I am giving all those features to my neural network. Yes, if these are the features, this is the output. Just like in the brain process, the learning takes place. So now I have data. Then how to test it? क्लास में हमारा टेस्ट होता है ना, क्विज टेस्ट, असाइनमेंट, ये वो. So how to test it? So one is test by your teacher, then finally the board exam. Okay, isn't it? So you know your testing school teacher जो टेस्ट करेंगे, जो सब्जेक्ट पढ़ाएंगे, अरे जो पढ़ाएंगे तो वही क्वेश्चन देंगे ना, और बाहर से कहाँ देंगे. But when you are appearing the board exam, you might not expect that. So for every neural network, one is training phase, one is testing phase, finally the certificate given stage validation. So training, testing, validation. What is the difference? Now the data which you have, you separate the known data into training and testing. So with known data you train it, then with another portion of the known data, you know that if these are the data, this is the output, then testing. So that is testing. Then now it is ready to put for board exam, validation. If something new comes, it can give result because you have tested with something. So unless you know what is the output, you can't test it. So that's why in training testing, I have separated the whole data into two classes. Whatever features you have, if these are the features, suppose you have taken feature from 100 male, 100 female and merge it together, and out of 100, let us 150 is pure, 50 is disease. So you say from 150, you select 100 for training, so another how much left? 50 for testing. From this 50, you take let us 40 for training and 10 for testing. So likewise, you are making your neural network train for that. Clear? But there is one problem. There is one problem. Suppose I have 10 classes. In this case, I have to diagnose whether a problem is there or not a problem. Suppose I am diagnosing a rare disease in biomedical science. Rare disease में कितना लोग होते हैं यार? डाटा कहाँ आएगा? Suppose the common disease जो आजकल है, उनका thousands number of data you will get. But some rare disease where you are getting only hardly 5-6 number of data points. So now suppose you have 10 classes. Out of 10 classes, 9 classes having 100 data points from these 9 classes. But another class number 10 is only having 10 data points. तो आप पहले क्या करेंगे? सब तो मिला दिए. सब मिलाने से कितना डाटा हुआ? 910. So 910 से आप randomly 70% सिलेक्ट कर देंगे for training. So 910 70% is 670 आसपास. Rest as training. There is one problem. Because you are randomly picking up 670 number of data points for training purpose. This may happen that out of the whole data set, the rare class which is only 10 may or may not be copied for training. So अभी suppose 10 से कुछ कॉपी नहीं हुआ ट्रेनिंग को, but टेस्टिंग को आप दे दिए. So what is the accuracy? What is the accuracy? For that particular class, the accuracy is 0 because it has not trained at all. You are giving some unexpected thing. Are you clear? So the simple way of dividing the whole data into training set and testing set by arbitrarily selecting 70, 30, 80, 20 like that doesn't work always when you have a rare class only having less number of data points. So that's why for validation of any neural network for classification or other purpose, we do k-fold cross validation or lambda fold cross validation. What is that? Then आपका जीव हो जाएगा. Now see, you break up. Suppose I have 5 classes. 5 classes. So 4 classes are having how many data? 100, 100, 100, 100. Another class is only having 10 data. So now I deliberately am breaking up into 5 groups of same size. So first data है. You have 5 classes ना? 100, 100, 100. 4 class का 100, 100. Another class is 10. So if I divide into 5, so each group having each class out of these 4 classes 20, 20, 20, 20. But the rare class data will be evenly distributed 2, 2, 2, 2. So now what you will do? You take combinedly 4. So the total data you have separated uniformly into 5 folds, 5 folders. So each folder having nearly equal number of data. It is not that always it will be divided by 5, but approximately near number of data. So the rare class 10 is now evenly distributed in each folder 2, 2, 2, 2. So now what will do? Take 4 folds together for training. So how many data of the rare class are guaranteed there in training? 8. Okay. 4 for training. 8 are there. Testing with only 2. You may get a better result. Now what will do? The same process is repeated. Now first one is kept for testing. All other 4 are training. Then you shift this. 5th one is for testing. All other are training. So likewise, you train your neural network for how many times? 5 times and take or report the average accuracy. At least every time it is getting some data points in the training set. So unless you have training, आपका पढ़ाया नहीं है क्लास में, पढ़ाया गया नहीं है क्लास में, बोर्ड एग्जाम में आ जाएगा क्वेश्चन तो क्या करोगे? 0. Your classification result fails. So that's why this is the uniform policy of testing any neural network for classification. Okay. Now here what I have done, how many of you are electrical engineering? Okay. So what I have done, I have just simply I am telling you many data from many of the power quality events like SAT, swell, transient, etc. So we are taking the information. Now see in wavelet I have already you are decomposing the signal into different frequency band. So if I am decomposing my wavelet into 13 level, and in each level I have to calculate some statistical feature. Simple I am telling just 2 lines. And then we will go the usefulness of this. Now see, suppose this is my signal XM. I am decomposing into wavelet level 1, level 2, level 3, like way 13 level. So in each level I am finding out different statistical feature like mean energy, standard deviation, kurtosis, etc. So what is my feature dimension now? For one particular event, suppose एक event, one particular event, now my feature set contains, what is the dimension? 13 into 7, 91. Because in each level you are getting 7. Level 1, then it's 7 features like energy, standard deviation, kurtosis, skewness, entropy, so 91. So for one data, a feature vector is having 91. If you train a neural network or test a neural network with 91 features, the time consumption is very high. So we are reducing the number of features by some evolutionary computing techniques like genetic algorithm or PSO. So this is one of the results I have reported, and this paper is recently coming in IEEE proceeding, generation transmission distribution. Okay, so only taking energy feature we have got this 97 accuracy, with entropy 97.9, when combined energy and entropy 98, all 96 feature 99.03, and the feature selected by genetic algorithm we are getting 99.3857. So this depends the sense that how you are extracting your important features from the signal. Okay, so fusion and all other things. We are not going into that. Let's see the application also a little bit on the bioelectrical signal, because as it was emphasis on this. So why nowadays this is important? This is important because of the e-health monitoring system. Nowadays you might have heard the Apollo Hospital of Chennai also, they are directly treatmenting the patient from that. So monitoring of the health of the people by means of this available communication technology, by means of the available signal processing technique, we are going for e-governance, e-monitoring, e-health system. So in this e-health system, you can check out your blood person's health conditions on web anytime, anywhere. So ultimately, what is to be done? Suppose I want to monitor Mr. X. So the data should be fed from that end. Then the doctor will take that data, analyze that data, put that data on the web server for the availability of that. So that is e-service. So in this e-service system, what we are generally doing, now see, we have some bioelectric signal. That is any physical quantity that varies as an independent variable and conveys information is a bioelectric signal. So all these bioelectric signals we are collecting. What are those signals? I will just tell you. What is the signal? The heart signal is known as ECG, electrocardiogram signal, and its range is only 0.5 to 4 millivolt. One ECG machine, it gives a signal of range 0.5 to 4 millivolt. Sometimes the signal level is so low that's why I have pointed out that you require some signal condition. You have to amplify this. Okay, then the frequency range is 0.01 to 250 Hz. These are the frequency range, and ECG is taken. You might have seen some electrodes are placed on the heart and the signal is taken. Similarly, another is the EEG, electroencephalogram. That is EEG signal. Its range is 5 to 300 millivolt and frequency starting from DC 0 to 150 Hz. Then electromyogram, the muscle signal, the muscle may strain away. Mainly orthopedic people, they take this signal which is known as electromyogram. You must be acquainted with this term. Okay. Next is electrooculogram. That is the movement of the eye. Depending upon your movement of the eye, that signal which will be produced, that is known as electrooculogram. Generally, you see, sometimes now we are doing a project under MIT, Massachusetts University of Technology, the identification of from the blind. When a blind person thinks, now see, somebody is blind from birth, somebody is not blind from birth. Suppose blind is blind from birth, आप उनको अब्दुल कलाम बोलेंगे तो क्या हो? There is some information. He tries to process that information. But if Abdul Kalam is told to me, I will also try to extract that information regarding Abdul Kalam. So we are studying the brain, on which part of the brain a signal will be originated. If it is a healthy person who knows Abdul Kalam, we have seen the picture of Abdul Kalam, and another blind on birth, another blind after some day who knows Abdul Kalam but become blind. So likewise, the distinguishing, once if something happens, there is a signal which originated on the brain. So taking those brain signals, how can you analyze? And oculogram signal, there are some persons physically completely disabled. And you know that eye is the only part of the human being which lives after the person is dead. Okay, that is the last most part of the human being. So even if somebody is completely paralyzed, not able to tell, not able to move, but he can give you some information by the eye movement, by the eyeball movement only. If you are asking him some questions or something, so from that eyeball movement, how can you extract important information? क्या बोल रहा है? Okay, so these are the nowadays also we are carrying out some work, so that is known as electrooculogram signal. Okay, at least you will get the last information from that. Similarly, the other signals like blood flow, respiratory rate, body temperature, glucose percentage on the body. Okay, of course these are some biological terms. Being an engineer, the basic thing also we have to know a little bit about that. So this is the important thing, the biomedical signal processing. Now the point is, you have the person from whom you have the sensing the signal, the required sensors are to be placed. Okay, electrodes are to be placed because for ECG, for EEG, the electrodes are to be placed. The next part is the signal conditioning. Already I have told to you. Then the signal processing. Once you do the signal processing, that means you apply your FFT, STFT, ST, WFT, whatever. Then you are getting some information. Then you have to display that information and you have to pass out that information. Okay, so that is the data display. Then data storage for future reference. Then data communication. You have to communicate this to the patient. Okay, so this is the whole system. So once you communicate, then there must be some feedback from the patient, because the diagnosis may be wrong. So it is, the whole thing is a completely new structure in case of e-healthcare system. Okay, and already I have told you regarding the noise sources and all other things. Suppose somebody is governing the health of the fetus. So when you are taking the health of the fetus, then the ECG of the fetus is also influenced by the ECG signal of the mother. So there is interference of the mother's heartbeat or ECG beat with the fetus beat. Now there is a challenge. You have to monitor the health of the fetus, whether he is healthy or she is healthy or not. Of course, she is crossed to know the condition of that. But in that case, there is a challenge. The interference is much more. The interference of the ECG of the mother is also superimposed on the fetus ECG. So how to remove that? Wavelet is a tool which we are using now also for the denoising principle or for the denoising. So these are the challenges nowadays. These are the different noise. So finally, you have the signal, you have the sensing element, you have the signal processing technique. This is just looks like a ECG signal. It will analyze the signal. Now what we are doing? We are processing this signal by means of suitable signal processing technique to extract the uniform or important features. And sometimes this may happen. Before doing that, in signal conditioning system, we analyze that also for making it noise free. So same signal processing technique like wavelet can also be applied for the noise, making noise free of that particular signal. Then this is a brain signal we are taking in our lab. This is set up in our lab, biomedical instrumentation lab. So you place the electrodes with a cap. The cap cost is 5 lakhs rupees. You put a cap and you put different electrodes. So there are 32 electrode or 64 electrode or 128 electrodes. So these electrodes have to be put. Why? Because you want to take the signal from different portions of the brain. Our brain is extended by different portions of the brain. Because sometimes you see, you might have heard this epileptic arrhythmia. Immediately. Okay, so whether that is present or not, to know, a certain part of the brain will be activated. Might have you experienced. We are thinking something more excitedly or more, some part of the brain becomes vibratory in nature. So the question is, we are monitoring the whole brain and we are looking into which portion of the brain is responsible for what work. That is the main identification. So that's why these are the signal, and again, whether you are monitoring your brain when you are sleeping, some patients come, they are unconscious. You are monitoring also. Some patients are also with conscious and you are taking. Some abnormal patients like, there are different type of abnormal who are taking monitoring also, they are moving some like that. It's भी हो सकता है ना? So that depending on that the frequency component also change. So that's why these are classified in delta. Delta means when you are taking EEG signal either in deep sleep or coma or in REM sleep. Either somebody is completely deep sleep or somebody is in coma. And coma कुछ तो होके coma हो गया ना, you have to take the signal analyze क्या हुआ है. Okay, or in REM sleep, very small stage when the brain was not developed. So those frequency range is only 0.45 hertz to 4 hertz. Why? उस वक्त ब्रेन काम नहीं कर रहा है. Slowly it is working. So if it is slowly working, what will happen? Time period will be large, frequency will be low. So that is the thing. Then, so these are the modes of this EEG signal. One is delta mode, one is theta mode, one is alpha mode, one is beta mode, and another is gamma mode. So these frequencies. So why I am telling all these points? Now depending upon the modes, you have extracted different frequency ranges. जैसे कि पावर सिग्नल में हम बोल रहे हैं कि our main interest is 50 hertz. If you are interested up to third harmonic, 150 hertz. If you are interested up to 10 harmonic, 500. Similarly, in your communication signal, whether it is AM band, FM band, or whatever, these are the different bands. So once I know these are the modes and I am getting one EEG signal, I can analyze which mode is dominant. So to know these different frequency components at different interval of time, either I can go for STFT or I can go for WT. Okay? So once you apply this, you can get some information regarding these different modes. That's why the very important point I have already told you, it is not only the signal which we are analyzing, we are analyzing also the characteristics of the signal. In power signal, what are the harmonic components present? When it is present? What type of transient signal is present? Whether the transient is initiated by a capacitor switching, whether a transient is initiated by some line switching or something like that. So similarly in the EEG signal, whether this signal, what are the different modes? कुछ समझ में आया? These are the 32 channel EEG signal. So simply look 16 channel EEG signal. Simply looking this signal, पता चलता है क्या हुआ है? How many electrodes you have? 16 electrodes. So all these 16 electrodes will give this, and ये तो चलता रहेगा. If somebody is in coma or something, you go on monitoring him continuously. So what section of the signal you will take? Which channel signal you will take for analysis? That is the prime part. So what section of the signal you will take? Which channel signal you will take for analysis? That is the prime part. Okay, so these are the different things. Now see, almost every signal looks like the same. If you see in your naked eye, just like that, या print out आपको दिया गया है, if you look into that, यार सब तो समान लग रहा है और क्या? You can't get any conclusion from that those signals. What happened? And which signal is of your importance? ये जो 16 channel लगा है ना, which is of importance? What you are going to analyze and which signal is dominant over the other? Okay, so coming to the next, these are the electrode placements. All 32 electrodes. So this particular electrode P4T6O2, this portion is mainly responsible for, because these are the extensive studies done by the medical scientists. So they have told me this particular portion of the brain is responsible for the detection of arrhythmia. So you take only those signals instead of going 32. Now you see, you are gradually increasing your complexity. आपका एक सिग्नल में मैंने 91 फीचर लिया था. If you have 32 signal, your feature will be 91 into 32. If you have 1000 patient, 91 into 32 into 1000. ये कंप्यूटर हैंग हो जाएगा. ठीक है? So the important thing is you must know which signals have to be taken for analysis and what you are doing. Whether you are going for arrhythmia detection, epileptic detection, or some other thing. So accordingly, the channel you have to select. So this is the 1020 international system of electrode placement, and you take those signals from that electrode. These are the two signals that I have noted. One is normal EEG, which is in black. Another is the epileptic seizure. The fits, epileptic seizure. So can you find any difference between these two signals? But actually, these are the two signals. These are taken directly from a patient in Sar Gangaram Hospital, Medawahari in New Delhi. That is a good hospital, particularly on this brain study, EEG study. So in that, with a standard EEG machine, we have taken these two signals and who will analyze this? मेरे को तो नहीं आता. One professor neurologist is there, Mandir Bhatia. So because doctor has to diagnose first. ये बाबा ये epileptic signal है, ये non-epileptic. Because they have the experience already. But if I will as an electrical engineer or you as a just signal processing expert, you can't find out any difference on these two signal by just looking into that. So what you will do by taking, first the doctor, she collects a lot of database from number of patients with epileptic, without epileptic. Then she will tell, ye epileptic, this is non-epileptic. So all the data are connected. And sometimes happen, even if the signal is taken and the person is chewing something, the signal behaves like an epileptic, but this is not epileptic. So all these data were collected by us, and next phase we have applied the wavelength decomposition to that signal. Okay, once I am applying wavelength decomposition, I have already told you, you are getting certain information in certain frequency bands. So these are the frequency bands, you are getting the information on that. So once these information are retrieved, now we are calculating the features. Now see, the epileptic and non-epileptic, which was not clear by looking into the signal, but once I have taken the two feature energy, just energy in third level and energy in fourth level, I have plotted. Now you see, the black ones and the blue ones are mostly separate. So you can distinguish. Now if some unknown signal comes to you, what you will do? Same wavelength transform, same technique you apply. Once you apply same technique, you are getting the feature. Then take the feature D3 versus D4. That means energy at third level, energy at fourth level. See where it is appearing. Because now this is your classification bound. This particular bound. Okay. This is your classification boundary. Because again, this classification boundary may be linear, may be non-linear. So people are going for better classifier like support vector machine and all things. But my emphasis is to show you it was not clear at all. Looking from the original raw signal can be achieved by means of a signal processing technique and a simple classifier. Okay. Again, we have tested the classifier with. We have taken a probabilistic neural network classifier. These are the different spread of the neural network, and these are the different classification accuracy with different feature. Now, in the first case, we have taken energy. Second case, we have taken entropy. Third case, we have taken the standard deviation of different levels, and these are the accuracy we are getting. Similarly, as I already told you, we are doing also a little bit work on this electro-oscillogram signal. These are the two channel EOG signal. So by taking the two channel EOG signal, we are analyzing what the person tries to tell us. Okay, or what information does it. This is a simple sample for you. This is for A. This is for A also. Character recognition based on eye. Based on eye movement, we are characterizing. These are the two channel movement. That means left eye, right eye, left eye, right eye. Okay. So take this signal and train your neural network or whatever you want for this. So mainly the objective of this analysis is information gathering, then diagnosis, then we are going for the monitoring, then therapy and all other things. So basically this will expose you to the area of the signal processing, how the signal processing is helpful for all this. This is not the end, we will go to the PS1s, told you. Okay, any question on this aspect regarding the signal processing, regarding the classification what we are using, regarding the information fusion, information retrieval and all other things?